So welcome back, Stella. We are to do this exercise precisely, the integral of cosec theta d theta. So I'll combine it with this question directly. We're going to prove that the integral of cosec theta d theta is equals to ln of the absolute value of cosec theta minus cot theta plus a constant k, which is the same as ln of the absolute value of tan theta on 2 plus a constant k. We have proved already this. So let's go directly to the task. So to gain time, I've solved it already, so I'll just explain. So our main aim is to prove that this is equals to this, which is equals to this. What you are supposed to do is to first find this integral. You get what I'm saying? Exactly as we did. We first start by finding this integral. We find this, we obtain an answer, and from there we shall arrange it for it to resemble one of these, and we shall prove that one of these is equals to the other. So that's why I first wrote, let's first find the integral of cosec theta d theta. Okay, we know that the integral of cosec theta d theta is equals to what? Integral of 1 all over sine theta d theta. Is that okay? From here, we know that we know what's the substitution. The substitution naturally will be, let t be equals to tan of what? The angle here divided by 2, because it's an integral of the form 1 all over a plus b sine n theta plus c cos n theta. Is that okay? So the substitution is t being equals to what? This angle divided by 2. From there, we calculate dt. dt will be equals to d of this. Is that okay? When we differentiate this, implicitly, when I differentiate this, I'll have half into 1 plus. You differentiate what is here, you write it outside, and you differentiate this without affecting the inside. That's basically the chain rule. So this gives 1 plus tan square theta, which is the same as sec square theta on 2. Is that okay? D theta, don't forget your d theta. From there, since we are making a change of variable, d theta will be equal to what? We make d theta the subject, because we shall substitute here. D theta will be 2 dt all over 1 plus tan square theta. Is that okay? Now, but we know that our t was equals to what? Tan theta on 2. So I substitute my t here. I'll have d theta being equals to 2 dt plus 1 t squared all over 1 plus t squared. Is that okay? Now, from there, we have to draw our right angle triangle. We have to draw our angle triangle, because we are doing a change of variables, so we have to find what will be sine theta. Is that okay? So let me go down. Let's now draw our right angle triangle to find sine theta in terms of t. Our t was equals to tan theta on 2. Is that okay? So this t is the same as t on 1. We know that tan theta on 2, tan theta, the tangent of an angle, is equals to what? The opposite all over the adjacent. Is that okay? Opposite all over adjacent. So t is the opposite and 1 is the adjacent. So I draw my right angle triangle. If I call this angle theta on 2, you can decide to call this, it depends on you. If I call this theta on 2, what is the side opposite to this theta on 2? It is this side. So my t will be on this side, and the adjacent to this angle is this side. So my 1 is here. Naturally, the hypotenuse will be what? According to Pythagoras, will be the square root of this square plus this square. Is that okay? So that's what we have. Now we have to find our sine theta. We have to calculate our sine theta. That's why I wrote sine theta is equals to what? Now, I'll first recall that sine theta, because in our triangle we instead have the angle theta on 2. So we cannot find directly sine theta from the triangle. I'll first recall that sine n theta, this is a trigonometric formula. Sine n theta equals to 2 sine theta sine n theta on 2 plus cos n theta on 2. Is that okay? Now, when I substitute 1 here, it becomes what? Sine theta. Is that okay? So this implies my sine theta will be equals to what? Where I see n, I substitute what? 1. Is that okay? Because we are finding sine theta. In front of theta here, it is 1. So my sine theta will be equals to 2 sine. When I replace 1 here, I have theta on 2 cos what? I replace 1, I have cos theta on 2. Is that okay? From there, I will have to calculate sine theta on 2 and cos theta on 2 from my triangle. So from my triangle, from my triangle A, I name the triangle ABC. I know that my sine theta on 2, which is opposite, sine theta is opposite all over hypotenuse, which will be t all over what? This hypotenuse, square root of t plus t squared. Cos theta on 2 is adjacent all over hypotenuse. So the adjacent side to this angle is what? 1 all over the hypotenuse, which is square root of 1 plus t squared. So my sine theta will be equals to what? 2. So I substitute this and this in this expression. So my sine theta will be equals to what? 2 times this times this. Is that okay? Okay, let me go up. So this implies our sine theta is this. I will then come. This implies the integral of 1 all over sine theta d theta is 1. I replace my d theta. We calculated d theta here. This is our d theta that we calculated here. Our d theta is 2 dt on 1 plus t squared. So I replace it where the d theta is up here. So I will place it here. All over sine theta, our sine theta is 2t all over 1 plus t squared. Is that okay? I'll rearrange things. This and this will go. Is that okay? And this 2 will go with it 2. And I'll be left with what? I'll be left with the integral of 1 all over t dt. We know that the integral of 1 all over t dt is simply equals to what? Ln of the absolute value of what? T plus our constant k belonging to r. Is that okay? So we then have this integral being equals to this. But recall that our t was what? Tan theta on 2. So I will just come and replace where I have t by what? Tan theta on 2. So the integral of this will be equals to what? Ln of the absolute value of tan theta on 2 plus our constant k. So we have already proved this. We've proved already that this integral is equals to what? This. Now, the last thing for us to prove this thing, we just need to prove that what? This is equals to this. Is that okay? So, if we are capable of proving that cosec theta minus cot theta equals to tan theta on 2, then we will have proved that this integral is equals to this, which is equals to this. Is that okay? So, now let's prove that this is what we are supposed to prove. Let's prove that cosec theta, there was no space here. We were supposed to continue it here. So now let's prove that cosec theta minus cot theta equals to tan theta on 2. Is that okay? Cosec theta minus cot theta, I'll start from the right side because it's very simple to go from here to prove this. So cosec theta minus cot theta is equals to what? The best thing, there is a secret I'm giving you. When you are given to prove a trigonometric identity, always try to write everything in terms of sine and cos first. Always do that. It's a simple trick I'm giving you. Always write everything in terms of sine and cos first. That's the secret. So this cosec theta is 1 all over sine theta minus cot theta is 1 all over tan theta. Now, this my tan theta is the same thing as sine theta on cos theta. Is that okay? So this, since there is 1 here, this will interchange. So I will have 1 minus sine theta minus cos theta all over sine theta. The denominator is common, so I just simplify the top. So I'll have 1 minus cos theta all over sine theta. Is that okay? Let me go on the next page. Now, this implies cosec theta minus cot theta equals what? 1 minus cos theta all over sine theta. Now, look at something. We are supposed to prove that this is equals to this. What do you notice here? There is already a half angle that's inside here. So, I must do everything possible such that in this expression I need to bring in half angles. Do you understand what I'm saying? For you to reach that level where you have tan theta on 2, This tan theta on 2 is already, this theta on 2 is already guiding you. It is telling you that try everything possible to bring out half angles. Is that okay? So from here, what I will do is that I'll find an expression for sine theta in terms of half angles and an expression for cos theta in terms of half angles. I'll say, recall that sine n theta is equals to what? 2 sine n theta on 2 cos n theta on 2. So this implies, if I replace here by 1, because our sine theta that we are finding has 1 in front here, I put 1 here. So it implies sine theta will be equals to what? 2 sine theta on 2 cos theta on 2. We have already our expression for sine theta. Now, I'll recall also for cos n theta. I gave these 3 formulas. Cos n theta is the same thing, is equals to cos square n theta on 2 minus sine square n theta on 2, or it can be equals to 2 cos square n theta on 2 minus 1, or it can still be equals to 1 minus sine square n theta on 2. Now, the question is, which formula am I going to use? Look at something. If we use this one, we come and replace it here. This one, look at it very well. This one, because there is a minus 1 here, is that okay? We're going to have this one. With this one, it will become plus. Is that okay? And the thing is also that cos will be present on top here, so that will be a wastage of time. Is that okay? Whereas if we use this other one, this one under here, when we substitute this inside here, you will see that this one will go with this one, and we will be left on top with what? 2 sine square theta on 2. Is that okay? When you look at this, what will be left on top? 2 sine square theta on 2 all over this. You see that one of the sine will go with this and will be left, these two will go with this and will be left with what? Sine n theta on 2 all over cos n theta on 2. That will give us tan theta on 2. So you always have to, first of all, test your things in the rough work. Is that okay? So I just wrote these 3 formulas for you to know the trigonometric transformation. So because I could just directly write this. Is that okay? So from there, this implies cos. So I replace 1 here because our cos theta, as we have to have cos theta, we have to put 1 here. So cos theta will be equals to what? I replace 1 here, and I will have 1 minus 2 sine square theta. From there, so this will be equals to this. So where I see cos theta, I replace by this. So I'll have 1 minus this all over 2 sine theta on 2 cos theta on 2, because this is sine theta. Is that okay? So this one will go with this one and we'll be left with 2 sine square theta on 2. Is that okay? All over 2 sine theta cos sine theta on 2 cos theta on 2. Now, sine square theta on 2 is the same thing as what? Sine theta on 2 all that square. Is that okay? Is that okay? Or sine theta on 2 times sine theta on 2. You see that one of the sine theta on 2 will go with one of the sine theta on 2 here. So we'll be left with one sine theta on, with sine theta on 2 here. And at the bottom, we'll be left with cos theta on 2, since these two will go with this. And we know that sine theta on 2 over cos theta on 2 is simply equals to what? Tan theta on 2. So therefore, we conclude that cosec theta minus cot theta is equals to what? Tan theta on 2. From there, we can conclude that the integral of cosec theta d theta is equals to ln of the absolute value of tan theta on 2 plus a constant k, which is equals to ln of the absolute value of cosec theta minus cot theta plus the constant k. So that's how you are supposed to prove that integral. Is that okay? That was a very simple question. Very simple question. So see you in the next video, where I'm going to, so we shall start with this part 2. I'll do this question. Yes, I'll do complete this question. It's a very simple question. You will see. I'll do that question. I'll also try to do this. Yes, I'll do this. I'll do this. I'll do this question. And from there we shall move to part 3, where I'm going to prove this. I'm going to prove this A, prove this B, and what are the questions am I going to do again? Yes, I'll do this and this. Is that okay? And you will have to do the rest. Is that okay? So see you in the next video. In the next video, where I'll start by doing yes, where we shall start with this part 2.